So this is 1-3, raising a power to a power. This is the third exponent rule. And it's actually dealing with multiplication. So the basic formula is a to the m to the n. So that's a power of m to the power n. And when we raise a power to a power, we multiply. So that's a to the m times n. And of course, I'll put numbers in there so you can see the difference. So here's an example with 5. Five to the fourth power to the second power means 5 to the 4 times 2, which is 8. The difference is the one we did before, we added the exponents, right? And this is a power to a power. Those were just two bases multiplied together. So this is multiplying, not adding. Example 2, x squared to the 5th power. So that's x to the 2 times 5 equals x to the 10th. Example 3 is raising a product to a power. I want to show you what that looks like. Raising a product to a power. Remember, product means to multiply. So here's what that looks like. So now I've put a 3 with the x. So that means 3 is multiplying x. That's the product. So this would be 3 to the 4th times x to the 4th, so you separate them. This power of 4 has to go with both the 3 and the x. And if I asked you to evaluate or solve, then you would do 3 to the 4th, which is 81. Any questions on that one? So this power goes with both things here. Okay? Here's an example where sometimes you'll have several different things, like this is an x cubed to the 5th times x cubed to the 2nd power or squared. Sometimes they're separated like this. So this is 3 times 5, so that's how we get the 15. This one's 3 times 2, that's how we get the 6. And then we go back a couple days where we added the exponents, and that's why I added them there. So step 1 is to multiply them. Step 2, add those exponents. You would get x to the 21st power. Any questions on that one? It's okay. I know it looks weird. We'll practice. So sometimes we have negatives. These are all positives, so I want to show you what happens with negatives and the errors that we generally make. So example 5, and we talked about this the other day a little bit too. If we have negative 5 inside the parentheses like this, to the 4th squared, then we just keep the negative 5, and we go 4 times 2, which is 8. So keep the negative 5, 4 times 2, which is 8. And the answer, if we work this out, will be positive, right? Because 8 is what kind of number? Even. Good. So even exponents with parentheses around the negative, that means this 8 goes to the negative 5. That will be positive. If I put the negative on the outside of the parentheses, see the negative out here? Remember that one where I did -1? I wrote in the -1 so you could see it a couple days ago. So if the negative's on the outside, you still do the 5 to the 8th, but you add the negative at the end, or multiply it at the end, okay? So this one would give us a negative answer, a negative outcome. And most of the time, they'll give you example 6 on a test or a quiz, just to see if you realize that the negative is not inside the parentheses. Most of the time, this is the kind of problem you'll see. Okay, so a summary of this raising a power to a power. When we raise a power to a power, we multiply the exponents. So think power to power, multiply. And I also put a little tip on the bottom if you want to write that down. So the tip is to pay attention to parentheses. If you see parentheses in a problem, they are very intentional. So that's it for 1-3, and then we're going to do 1-4 before we do the practice. Any questions on raising a power to a power? So if you see this, power to a power, you multiply. Okay, so 1-4 is division with exponents. This is the one where people get really mixed up and confused. So it requires a little bit more practice and a bit more of writing things out in that expanded notation, that expanded form. I'll show you why after this. So here is the formula for division. A to the n over a to the m equals a to the n minus m. So you can see that when we divide, we're subtracting. So here's an example of one. If we have 3 to the 7th over 3 to the 3rd, you just subtract 7 minus 3, and that's 3 to the 4th power. And you'll be able to leave it like this unless it says solve or simplify or evaluate. But just like that is fine. Any questions on that one, the subtraction? Subtracting is easy. It's just that when they get more complex, people miss these problems. They're easy to miss. Example 2, z to the 10th over z to the 5th So that z to the 10 minus 5 equals z to the 5th. Remember, you don't have to write out this step every time once you start doing your homework and stuff. That's just for you to see what I did. You don't need it every time. Okay, example 3. See how this one looks kind of crazy? That's what I mean by getting confused. So I'll break it down for you. So I have 5 to the 4th power times x to the 3rd power over 5 squared x. So I'm going to separate the 5's from the x's at first, okay? So this is 5 to the 4 minus 2. These are the 4 and the 2. And this is x to the 3 minus 1. You have to include that imaginary 1 there. Everyone see where the 1 came from? Right here? Okay. So this is 4 minus 2 is 2, so 5 squared. 3 minus 1 is 2, x squared. And this looks kind of funny to us, so I'd say if it looks kind of funny, let's multiply that out. 5 squared is 25, right? 5 times 5. And just leave it at 25x squared. When you guys get good at these, you don't have to do this step, okay? You'll probably, some of you, get right to that step. You'll see it so fast. You'll get right to the end and have your answer. Okay, here's another one that looks kind of interesting. I have a negative 3 in parentheses, y to the 4th power, over another negative 3 in parentheses, y. So I see parentheses, so I'm going to keep them there when I rewrite it. This is 2 minus the 1, imaginary 1. You have to always include that. So this is negative 3, because 2 minus 1 is just 1, right? So negative 3. And then the y, 4 minus the imaginary 1 on the y is y cubed. And then you're done. That's it. Some of you might already be, you might be seeing shortcuts. And that's good if you do. Because these will come up again in high school, math, a lot. So if you're seeing the shortcuts now, that's great. Don't worry though, I'll show you them eventually, right? Okay. Example 5. Look at that one. Wow. What a mess. This is negative 4 to the 5th times negative 2 squared times negative 5 over negative 4 squared times negative 2 times negative 5. I put them all in parentheses so you could see them better. I also line them up so you can see them better, but they're not always going to be that pretty. So let's start with the negative 4's. We have 5 minus 2, that's this one. 5 minus 2. On the negative 2's, we have a 2 minus an imaginary 1. 2 minus 1. And on the negative 5's, they would each have a 1. So we just write that as 1 minus 1. So what should this first one be? Negative 4, 5 minus 2, what is that? You guys can say it. 5 minus 2 is 3. And then this one should just be a negative 2, right? Because negative 2 to the first power is just negative 2. What's this one going to do, this negative 5? It'll be gone. Anything to a 0 power is 1. Okay? That's another rule that we're going to look at later. So this should be your answer right here. So negative 4 to the 3rd power, that's the 5 minus 2, times a negative 2 times 1. You don't have to write the times 1. I just wanted to show you where the 5 went. The negative 5. And then the final step would be either plug it in your calculator or the MyScript app, and you end up with this. Negative 4 cubed is negative 64. Because that's 3 negatives, right? An odd number keeps it negative. Times this negative 2 times the 1. Well, these two negatives will make a positive when you multiply them. So we just get 128. So raise your hand if you're feeling a little confused by this one. That's normal. So on the next page, I'm going to show you the expanded form. It might start to make more sense. Okay? Got this? Okay, so this is what it looks like in expanded form. This is about a half a page more of notes, and then we're done with notes. So write down expanded form. That's just something for you to get used to. Terminology. And then we have 4 examples. The first one, keep it simple, is x to the 5th over x to the 4th. So we would subtract these, right? 5 minus 4 is 1. And look at my answer. My answer over here is x, so that's x to the 1st power, right? This is how you do this. If I were to expand this out, I would write 5 x's on the top, 4 x's on the bottom, and then it's like a 1-to-1 cancellation. So I have 1 on the bottom, you always start with the bottom, and 1 on the top. I have another 1 on the bottom, cross out the 1 on the top. This one, that one, that one, that one. I'm left with 1. There's my answer. So if you ever get a problem like this, or the ones on the other page that were more challenging, you could expand it out just to make sure you're doing it right and cancel things out. You could do that. Unless you just remember to subtract, and then you don't have to do this, okay? Here's another one with numbers. 3 cubed over 3. So I have 3 3's on the top, 1 3 on the bottom. Cancel the bottom with one of the ones on the top, and I'm left with 2 of them. And that's 3 squared, and you could also say it equals what? 9, good. 3 times 3 is 9. Does this help seeing it this way? A little bit? You can see why we subtract. Here's another one. This is one where you might have letters and numbers combined. So this is 4 squared times a to the 4th over 4 times a squared. So on the top we write 2 4's, the bottom gets 1 4, right? The top 4 a's, the bottom 2 a's. Start crossing things off. And you're left with a 4 and 2 a's, and that's 4a squared. Or you could just subtract. 2 minus 1 would leave you with 4. 4 minus 2 would leave you with 2 a's. Either way is fine. This one has a star by it. It must be a good test question. So I see parentheses, I see negatives. It's still the same process though. Negative 3 squared times negative y cubed over negative 3 times negative y squared. So I have 2 negative 3's on the top, 1 on the bottom. 3 negative y's on the top, 2 on the bottom. Start crossing things out. You can circle what's left over. So, what's left over? A negative 3 and a negative y. So that is negative 3 times negative y. The negatives turn into a positive, and that's just 3y. Here's the summary of what we just did. When we divide values with exponents, this little w slash with, okay with that? When we divide values with exponents, we subtract. We subtract the exponents. Any questions? Do you guys think you'll use the expanded form, or will you just subtract? Raise your hand if you think you'll use expanded. Raise your hand if you think you'll just subtract. Raise your hand if you think you'll use both to make sure you got it right. On a test, right? Good. 2 methods. Some people like this better. They can just cross things out and make sure they did it right. Other people are great with just subtracting and keeping it organized. Okay, so now we've got through 4 of those. And remember I said there's going to be 8. So that's good news. We're halfway there.